we have a SAT math question. Here we have a table of values for x and the function f of x. One of the factors of the function f of x is x positive k. Given that k is a positive integer, what is the value of k? Okay, before we start solving this problem, I consider a factor theorem. That is, let's understand factor theorem. Okay, say x negative a is a factor of, let me write the stuff over here. It's a factor of a polynomial function f of x. Okay, so here I'm saying that x negative a is a factor of a polynomial function f of x. Now what I'm going to do is I'm going to equate this factor x negative a to 0 and solve for x. So when I solve for x, I'm getting x equals to a. Okay, now what I'm going to do is I'm going to plug in this value a for x into the function f of x. So then I'm getting f of a. Since x negative a is a factor of the polynomial function f of x, the value of this f of a must be 0. So this is called factor theorem. And here we have a question. What if f of a does not become 0? Then this x negative a is not a factor of f of x. So whenever x negative a is a factor of f of x, then we have to equate this factor to 0 and solve for x. And whatever value we are getting for x over here by equating the factor to 0, it has to be plugged in for x into the function. And when I plug in this value for x into the function, it has to result 0. Then we can say this is a factor. Okay, now let's use factor theorem over here in this problem. So the information we have over here says x positive k is one of the factors of f of x. Since x positive k is a factor for this function f of x, first what we have to do is we have to equate this factor to 0 and solve for x. So when I solve for x, I'm getting x equals to negative k. Now, according to factor theorem, if I plug in x equals to negative k into this function, so that is f of negative k, it must be equal to 0. So because x positive k is a factor for this polynomial function f of x. Okay, now what I'm going to do is in the table above, I'm just going to consider the cases where the value of the function f of x is 0. So there are two cases. That is when x equals to negative 5, the value of the function f of x is 0. And when x equals to 2, the value of the function f of x is 0. That is f of negative 5 equals to 0 and also f of 2 equals to 0. Okay, here we have 0 on the right side. Here we have 0 on the right side. At the place of negative k, what do we have over here? So at the place of negative k, we have negative 5. So we can say that negative 5 equals to negative 5. So here also we have the value of the function is 0. Here also the value of the function is 0. So at the place of negative k, what do we have over here? We have 2. So we can say that negative k equals to 2. Okay, now we got two equations for the variable k. So now what we have to do is we have to solve for k. So to solve for k in the first equation, I have to get the negative sign. So for that, what I have to do is I have to multiply both sides of this equation by negative 1. So when I multiply this one by negative 1 times negative k is positive k, negative 1 times negative 5 is positive 5. Okay, the same thing. So we have to get this negative sign to solve for k in this equation. Further, I have to multiply both sides of this equation by negative 1. When I multiply this negative k by negative 1, it will become positive k. When I multiply this positive 2 by negative 1, it will become negative 2. So I am getting two values for x. One is k equals to 5 and other one is k equals to negative 2. So, but the information says k is a positive integer. So in these two values, which one is positive integer? Clearly 5 is a positive integer. So negative 2 is a negative integer. Since it's here k is getting a negative integer, we can reject this one because according to the question, k must be positive integer. So therefore the value of k is positive 5.